Pessoal, bem-vindos ao campus. Eu sou o André. Essas são as últimas palavras que eu vou falar em português. So we're switching to English because this is an English-only event, and we have hosts. We have people to host in the house, and we want to make them feel comfortable understanding what we're saying. So it's a pleasure to have you all here. We're kicking off the open events for Campus Expert Summit today. We had Marilia Mello talking about GCP, Google Cloud Platform. And now we're going to have Onome, who will be speaking about the buzzword of the hour, machine learning. So Onome is from Nigeria originally. She's been at Google for 2.5 years now. She's based in New York, and she's part of the search team. And she's going to tell the bits and bytes about how we're using machine learning, and more importantly, how you guys can use machine learning. That's it. So with no further ado, please welcome Onome on stage, please.
Hi, everyone. Thank you for the warm welcome. It's great to see so many faces this late in the day. So I have 2 requests really quickly, just so the time can pass really quickly for all of us. If you can participate, there'll be some points where I need some comments, some suggestions. So if you can participate, that will help us, get through the slides quickly. And then the second thing is, as we go through and as you learn more about the APIs that are available, I know some of you are already using machine learning in your apps, but if you're not, if you can think of ways that you can potentially apply machine learning, I would take some suggestions at the end if any of you want to share the ways that you've thought about based on this slide. So let's get started. Just a quick show of hands. Who is an expert on machine learning? Expert? No. Okay, so none of us, right? Who has used any? Oh, one person, great. So you're going to be helping me out. One at the front, one at the back, great. Who has used any machine learning APIs? Okay, a few hands, but this seems like the great audience, right? Because what I'm going to share with you today is how to use the APIs, what the APIs can do for you, and how to get onboarded really quickly. So I'll first share quickly what I think machine learning is as a concept, and then I'll share with you some of the machine learning APIs. I'll share with you TensorFlow, which is a way you can create your own machine learning model, and also how you can use TensorFlow to use other people's model, retraining it with your own data. So machine learning as a concept. So let's imagine you wanted to build an application for children to learn about fruits. If you wanted them to, take a picture with their camera, upload it to the app, and then your app would label and teach them what exactly the fruit that they took a picture of is. So let's say a child uploaded an image of an apple and an orange. What are some of the ways that your app could figure out what fruit was actually uploaded? So what are some features you might... Color, okay, so red versus orange. What if it was black and white pictures? Okay, I hear texture, so shape as well, right? Like smooth versus textured. But what if instead of an apple, we had a pear, same texture? And what if instead of pear, we have a grape, so same color? So the idea is that as you keep on adding more parameters, more different kinds of inputs, you need more creative ways to figure out what exactly your data is, what exactly the fruit is for the kid. But if you think about when you were a child, how did you learn about what different kinds of fruits were what? Your parents probably told you, or you learned in school, or your teachers, or your friends, or you learned in books. And then now you can easily tell, okay, this is a pear, this is a grape. So the idea of machine learning is essentially taking what we do as humans. So we learn through experiences, through what other people have told us. And then using the learnings that we have over the years, we are able to make predictions about what something is today. So essentially using knowledge of old data to create a model or a framework from which to predict knowledge about new data. So essentially that's machine learning as a concept, teaching the machine how to learn. So what does the landscape look like for machine learning today? There are mainly 3 ways you can get started. The first is using a cloud-based or mobile-based API, which I'm going to talk a lot about today. The second is to use an existing model, so an existing framework for the computer to learn, and then fine-tune it with your own data so that that model works better for your use case. And then the third way is, just develop your own model. If you're doing something complicated, something that's not really been done before, which I know a lot of you are doing, you might need to create a new model. But the problem there is you need a lot of data. Otherwise, the model is not going to work as well. So, based on how flexible you want to be, or based on how much data you have, you can decide which of these approaches to take. So just as far as Google Cloud is concerned in machine learning, the ones on the left, so TensorFlow and Machine Learning Engine, these are the custom ML models. These are the models that you need data for. And then the ones on the right, they're the pre-trained models that you can start using today because they run based on existing models that Google has created already. So these are what I'll talk about now. So the first one is the Vision API. This API, you can use it today, totally free to a certain point. It essentially allows you to analyze images. It can detect faces in an image, so your emotion, the different landmarks, so your eyes, your nose, and so on. It can label images, so tell you what the features of the image are. So in this particular case, it's a transportation image. It can detect text on an image, identify logos, tell you whether the image is safe for work, and also detect landmarks. So I'll just give a quick demo of what it can do. So if you go to cloud.google.com/vision, you can try the API out by uploading an image. So I'm going to upload an image of Christ the Redeemer. And I'll show you the insights you can get from it as soon as it loads. All right, there we go. So right now, it's labeled this image as, it's 92% sure that it's a landmark, it's a geographical feature, and there's a mountain, and that it's a picture that depicts tourism. Some other things it can detect. It detects that the entity in it is actually Christ the Redeemer, which is what it is, that it's in Rio, that there are cities, that it's an image. Also detects that Rio and Brazil are features of this image. Additionally, this is actually a new feature. It can essentially do a backward search of that image on the web. So these lists of links are places on the internet where you can find the exact same picture. I can open one of them if we have time. We'll see if it loads. But you can find exact matches, but also partial matches. So websites where there are partial matches of this image. And essentially what is returned to you if you use this API is essentially a JSON response. And the JSON response has descriptions of the image. So it's a landmark with this particular accuracy. It's a geographical feature with this particular accuracy. So you can think about creative ways to use this kind of knowledge of images within your app. And the next one we'll talk about is, just really quickly actually, how you use this within an application or within a web app. It's essentially just a call to a REST API. So you create a JSON request that has either a link to the image or a pointer to the image stored somewhere in storage. And then you send that to the REST API, and what you get back is the JSON response that I showed you from that website. It's very, very easy to use. So the second one is a natural language API, and it allows you to do syntax analysis on just human written words. So it allows you to identify the different parts of speeches, the pronouns, the nouns, the verbs, and so on. And it allows you to recognize entities in a sentence or to analyze the sentiment of a sentence. So whether it's sad or happy and so on. So quick demo of that. So again, it's cloud.google.com/natural-language. And I will type Let's analyze that. Okay. So the entities that it's highlighted here are Brazilian in food with certain accuracy scores. And then there's the sentiment, like what exactly is this sentence depicting? So it's telling me that it has a score of 0.8. So this is a good score. Anything positive is that the sentence has a good score, a good sentiment. If it was negative, then it would be that the sentence has a bad sentiment. And then finally, you have the syntax. So it tells me the pronoun, the adjective, the verb, the adjective, and the noun. So one really cool way I've seen this used is by people who run large-scale events that have, Twitter hashtags. So people are talking about the event on Twitter, and then they can scrape Twitter for tweets with hashtag of their event, and they can get an understanding of what kinds of words people are using to describe their events. So if most of the adjectives are, oh, this is great, this is amazing, then they know that they've done a good job organizing an event. So you can use this also to determine how people feel about your apps on the App Store. What are the words that you use most to describe your app, for example. And then the final one I will talk about is the speech API. So this is used in a lot of Google products, actually, and it's used for voice recognition. It currently recognizes more than 80 different languages, and it can recognize streaming and non-streaming. It can also filter for inappropriate content, handle noise, and also it's integrated in a lot of different other APIs. So I wrote, actually I pulled a script that can help us demonstrate this. So open up Bash, write some code, maybe. Make this bigger. So I have a Bash script called request.sh that will prompt me to enter, to say something, say a phrase, and then it will send that phrase to the speech API and then print what the speech API sent back to it. So essentially it's a voice-to-speech, text-to-speech script. So I'm going to run it. Press enter when you're ready to record. I love Brazilian food. Press enter when you're ready to call the speech API. Okay. So just a few things here. So I also printed out the JSON request that was sent. So this is a JSON request. It has the language that it's using. It defaults to English if you don't set a language within the call. But you can change it to any of the other 80 languages that are supported. And then there's a speech context object, which you can actually use to denote phrases that maybe are not part of the language that you're actually using. So let's say there was a phrase or a word that is not easily recognizable, or it's not in a dictionary, or it's colloquial, or for example, anything like that, then you can set that in here. And if the API recognizes a word that's similar to that, then it would change whatever word it heard to the word that you told it to use. But then you see here in the response that was sent back to me, I love Brazilian food, which is what I said. And it knows that that's what I said with an accuracy of 94%. So this is what's used in some of the text-to-speech apps at Google. So it powers OK Google on your Android phone, for example. All right. So just some of the resources that I used for these demos. So these are the links to the Vision Speech Natural Language and Translate APIs. You can check that out. So in addition to these APIs that you use on web apps, you also have a similar counterpart on the mobile vision. So it essentially allows you to do this on iOS and Android phones without any server calls. So it all happens on the client side. And there are three main APIs for that. There's the face API, so same thing, recognize landmarks on the face. There's barcode API for recognizing barcode. And then there's a text API for reading text from image, so OCR detection. So this is an example of the sort of thing you can do with the Face API. You can essentially detect different parts of your face and then draw some features on it. So if you think about Snapchat and how they put filters on top of your head or add things to your eyes or your mouth, they essentially are able to detect a face in an image and then draw different things on top of that face. And it's a very simple method to write. So you essentially first create a facial detector, then you detect the faces in the image, and then detect the landmarks. So the landmarks are just, the eyes, the nose, the mouth, and so on. So very simple to use API. For text detection, it can detect the text on the fly as you hover your phone over it. So in this case, it's recognizing Latin-based text on documents and so on. It can also detect text structure, so it can detect blocks of text versus lines versus actual individual words. And then finally, there's the barcode detection, so it can detect 1D barcodes versus 2D barcodes like QWERTY. So I imagine there are tons of applications of these kinds of detection in different apps. And the final thing I'll mention is, I don't know if many of you use Google Translate, but essentially it's one of the apps that chains together multiple APIs. So it uses the Vision API to detect text on an image, and then it uses a Translate API to translate the text that it detected. So it's a very, very cool application of that. So some more code labs and samples that you can check out. So the ones for the googly eyes, code lab for facial detections, and then some GitHub code samples of how people are using this today. All right, so we just talked about the machine learning API. So it's the easy way to get started for people who are looking to just figure out what machine learning can do for them right now. But what if you're a little bit more advanced? What if you have some data? Or you want to see what other models people have created? Then there's TensorFlow, which is an open source machine learning library. It's the highest rated library on GitHub for machine learning right now. It's especially useful for deep learning, and it's used by a lot of researchers, data scientists, and so on. So what's the concept that TensorFlow is based on? It's essentially based on a field of artificial intelligence known as deep learning. And the idea of deep learning is that as you go through different layers of a neural network, think about the brain. There are different neurons in the brain that's responsible for doing one particular thing. So the idea of deep learning is having a bunch of different layers in what's called a neural network that's responsible for processing just one part of a complex computation. So in this example, let's say you wanted to figure out whether a picture is of a dog or a cat. You would have many layers that's responsible for doing just one thing in that process of figuring out what this image represents. So for example, the first layer can say, okay, does this animal have 2 legs or not? And so as you go through each layer, you ask that question, yes or no, and then at the end, the result is either a dog or a cat. So more concretely, though, what happens when you start a neural network with no context on, no modeling done? So let's say you have a neural network that's created from scratch and it hasn't had any data passed in through it. So it doesn't know anything about the kinds of data you're feeding it. How does it get trained? The idea of training really means that you're sending it data and you have some output that you're gleaning what it does against. So let's say you have a picture of a dog. You know it's a dog. You pass it through your neural network, and if it returns not dog, then obviously something is really wrong in your network. So you use backward propagation. This is a technical term, but essentially you use the knowledge of the fact that the neural network did something wrong to then decide how to weight the different layers of your neural network. So maybe one part of your neural network has a negative weight, and then because of that, it has caused your response to be wrong rather than right. So essentially, you use the knowledge of what your data is supposed to be you use the knowledge of what the response from your neural network is supposed to be to then decide what different weights you give the layers of your neural network. I know this is very, very complicated. It's hard to explain in a 1-hour talk, but that's just the general idea of what a neural network is. Essentially, layers of neurons, like in the brain, that do one specific thing, and they have specific weights that are then used to make a general, or to create a general answer to a specific complex problem. A lot of people ask me, what does TensorFlow mean? As a phrase, it doesn't really have any meaning in English or any other language. But tensor is essentially it's a multidimensional array, or it could be a scalar. It's just something that holds data, something that has some sort of knowledge in it. And the idea of flow is essentially the idea of going through a graph of operations that corresponds to a computational problem. So when you say a tensor flows, you're just saying that your data is going through a bunch of different operations that would, at the end of the day, give you some sort of result. So for flow graphs, data flow graphs, or tensor flow graphs, because tensor is just data. So for tensor flow graphs, is essentially a way to optimize an objective function. You can think about it that way. But at the end of the day, it's a function, a computational function that has been reduced to a set of different flows. And usually for TensorFlow applications, they're defined in Python, and they're compiled in C++ usually. And then the graph is always executed and available on low-level devices, so CPUs or GPUs. And TensorFlow allows you to also compute the gradients or the weights that I talked about before automatically, based on it learning more knowledge based on all the data you're passing it through. So this is why people normally say the more data you have, the better, because as you keep training your model, it learns and adjusts the weights based on more data that you pass in. TensorFlow is also very portable and scalable. You can train on many different devices, Mac or Windows, GPU servers, and so on. And you can predict on also a bunch of different frameworks, so Android, iOS, Raspberry Pi. And I'll talk about some examples at the end of some applications of TensorFlow on Raspberry Pi. Finally, TensorFlow has an open source solution for serving trained models. So imagine you had some sort of image or data classifier that was creating models in production. So you have to think about, how exactly that data is being computed. I mean, training models is a very computationally expensive thing, and it's not something you really want to worry about day to day. But TensorFlow allows you to handle that automatically. And I think Marilia talked about this earlier today in the cloud workshop. But you can check out TensorFlow Serving to see how best to operate your models in production. Finally, I wanted to just highlight the TensorFlow community and ecosystem. So Snap is one of our big users. Google obviously uses the machine learning it creates, Twitter, eBay, and so on. And tutorials are available on tensorflow.org. All of the stuff I talked about today is there, but there are also code labs, quick starts, and so on. So if you're interested, please check it out. So I talked about the APIs, I talked about TensorFlow as a concept, but let's say you don't want to train a full model. Let's say you just want to retrain a model that someone else has already created. So actually, I didn't mention this, but one of the beauties about TensorFlow being open source is that because a lot of people are working on it every day, they're creating their own models. So if there's a model that someone else has already created and you think will work really well for your use case, you don't have to rewrite it. Let's say there's just something very particular to your use case, you can just retrain it using some of your new data, and then you've cut 1 or 2 steps. You're ahead of the game because you can reuse something else that someone has written. So how do you do this? So an example is TensorFlow for Poets. So this is essentially a code lab on how you can retrain an image classifier using only 50 new photos. So there is an image classifier called Inception that can classify a bunch of different images, cats, dogs, humans, and so on. And you can retrain it with your own specific niche of data. So let's say, for example, you wanted to be able to classify images at a museum, for example, paintings. So you can take 50 pictures of paintings you're interested in and use that as input into the pre-existing model called Inception. And the process doesn't require any code, but the code lab takes you through all the steps you would need to do on how to retrain a model. You can read the source code for the code lab and use that to extrapolate onto different kinds of other models. So this one is specifically for images, but you can see how you could do this for other sorts of data as well. TensorFlow also is available on mobile, I mentioned before, so on Android and iOS. And the idea here is, not that you're doing the modeling on the server, you're doing it actually client-side, which is really cool. So this is just a picture of an app that was created using a model that was trained using new data from a museum. And so you can see that they're able to properly classify this painting of Monet's sunflowers based on the existing model that Inception had. So some examples of machine learning right now. So this is a cucumber farmer in Japan who's actually using TensorFlow in his farm to decide which are good cucumbers and which are not so good. So according to him, he has 9 different types of, or 9 different buckets into which to sort cucumbers. And he was able to come up with a model to do this based on taking pictures of lots of different cucumbers and then training the model based on the types of cucumbers for each different bucket. I would play this video for you. Actually, let me see if I can do it. So essentially, he uses Raspberry Pi. So there is a camera at the top of the device in which he places the cucumber now. So takes a picture from all different angles. And based on the model that he has trained to recognize which of these 9 buckets it should fall into, it decides where to move the arm. So in that case, that cucumber is for BM. And so on and so forth. I think this is a really cool application of TensorFlow because it shows that this can be used by anyone. I mean, a farmer could use this. And then he was able to create a way using TensorFlow, using the data he had to come up with a creative solution for sorting cucumbers, which would normally take multiple hours and is not really the job of a farmer. A farmer wants to farm, but TensorFlow is now allowing him to use his extra time to actually farm rather than waste it sorting fruit. The second example is TensorFlow plus Raspberry Pi for sorting garbage. So it's a similar one as the cucumber sorter, except here we're doing compost versus recycle. So again, there's a camera at the top that takes a picture of whatever trash you put on the garbage can, and based on the model, which learns whether it's compost or recycle, the cover of the bin flips one way versus the other way. And then just in the everyday products we use, so Google Play, for example, uses machine learning to understand what kinds of things to recommend for you based on the things that you've looked at before. Gmail uses it for deciding which messages were sent to you aren't suitable for work or which are spam, and then this is how it decides what things to send to the spam inbox. Google Photos, which is one of my favorite apps, is able to classify the different kinds of images or photos that you take with it. And so, for example, if you take a lot of pictures of your dog as well as selfies and so on, but you want to show someone a picture of your dog that you took, let's say, a month ago, you can just search for dogs, and because it has used the Vision API to actually understand what kind of image it is, it's able to return you the pictures of just your dog. And I mentioned before, we use the Speech API for OK Google functionality for text-to-speech. And then finally, I think this is my last example, there's the smart reply in Gmail. So this uses natural language processing to decipher the syntax and the sentiment of messages that are sent to you. And based on that, it can make recommendations on what are the kinds of responses that you could send so that you don't have to type anymore. You can just click, oh, I don't, sorry, or I'll send it to you, for example. So it uses machine learning to understand what someone else sends to you, and then based on that, makes recommendations that could be easier for you to just click on rather than typing. So that's all from me. If you have any questions, you can share them right now, but I'll put up a slide that has just some of the resources I shared in case you missed it before, so you can take a look later. Thank you. By the way, if anyone has any questions, you have to use this thing. Throw it.
Is it working? Yeah. So you mentioned about the language API, right? The natural language API, that it can understand different idioms. But what about like different ways that the language is used? For example, you might have a text that belongs to an engineering field, or legal, or Shakespeare, or Game of Thrones, medieval warfare stuff, where they use your grace all the time, or these specific worlds where language is different, all within English, let's say. Does that work? Is it a different idiom? How does it handle that? Can we train it on specific data like that?
So that's a good question. And the question is essentially, like languages or you can use the API for natural language, but then sometimes there are specific idioms for different kinds of fields, so engineering versus marketing versus Game of Thrones. So can we train the API to do that? So the API is closed, it's not open for training. It can recognize entities in specific sentence. So let's say you type a sentence about Khaleesi. It will send you to a link of Game of Thrones. Khaleesi is actually, I think she's an entry on Wikipedia. So it can recognize the fact that Khaleesi or a Game of Thrones entity is a Game of Thrones entity. But specifically whether you can train a model or train that API to recognize different kinds of idioms. You can't train the API, but you can train a model to do that. So right now there's some natural language models available on GitHub via TensorFlow. So you have to look specifically in the contrib folder. So these are contributions from other people in the open source community. So there's some natural language models there, and you can actually train it specifically to recognize, let's say, idioms in engineering.
For example, I'm asking this because if you take a legal document, to understand the sentiment of a legal document, it's really hard because they are prolix. They write a lot, to say just a little sometimes, which is different from
I understand, my sister is a lawyer.
Engineering, we have numbers in the middle of the sentence, and you have to make sense of the numbers. So
I think that if you have a specific issue like that, or that's a specific problem you're trying to solve, you have to make sure that the model actually understands that specific discipline. You can't have a generalistic model. It won't be quite as accurate as it could be. So yes, it will be very, if you want to solve a problem like that, it would have to be specific to whatever area you're interested in, yeah. Just pass it.
At the company I work for, we use Google API to do OCR. So we have our clients send an image we pass through Google API to extract data from this image. But we are having some troubles with the patterns of the image they send. We don't know how the image are going to be, if he's taking the right picture and the right position in the document. So we kind of have some guys are on our team that have to check each image to see if the data are right. So what do you suggest for, is there another API that we can use?
So I'll be interested in learning more what you mean when you say the data is right, because the API works really well even though the image is sideways or upside down. It's able to like fix or it's able to fix that and correct for that. So when you say to correct the image, usually what does the other person have to do before it's sent to the API?
We have to check like if the labels were right, like the name of the guy, like in his ID is complete. Like if it's a long name, it has 2 lines, and we have some like different patterns. So some people send like it's a green document in a green environment. So sometimes it confuses and don't extract all the data that the document has.
I see. So this is actually for the output of the API is not as good as it could be. That's what you're saying. Okay, I see. Yeah. So I'm not sure when this happened because the API is constantly being improved. So it's being worked on by countless engineers and also the open source community. And so there was a new release recently in March. So probably some of the issues that you're talking about would have been solved by then. But I do agree that that is a gap. You know, machine learning is actually never perfect. So one thing you can take a note of is to actually pay attention to the confidence score. So you don't have to, if the confidence score is high, then probably everything is okay. So maybe you could have streamlined your process to only have someone look at the results if the confidence score is maybe lower than 95% or 80%, pick some number based on the data. Does that help?
Hello. Is there any API for handwriting understanding?
MNIST. So actually, the first link on Guides Codelab videos, MNIST, that's for handwriting recognition. So it's not 100% accurate because handwriting is a tough problem to solve, but it is being worked on. But you can find more details at that link. Yeah.
Thank you.
Any other questions?
Hi. When you train your model and you need real-time training and response, do you have any APIs at Google Cloud, to train that data, like stream data, and then regain the weights in our model, like training real data?
So real-time training of data within
Yes.
your application?
Yeah. That real-time data training.
Real-time training of data.
Yes.
So, I mean, are you using TensorFlow?
Actually, I'm aiming to use the APIs, not
okay.
TensorFlow itself.
So the problem is
But
you can't train the APIs. The APIs are sort of a black box. And so there's no, you can't have any control over what the model is based on the input data you send.
Okay, but we can publish our TensorFlow model
Yes.
to Google Engine and then have that data trained.
Yes, and then it's
Okay.
real time in that case, yeah.
Okay, thank you so much.
There was one in the very back. If you can just pass. Thank you.
Okay, yeah, so the first part of my question, I wanted to know a little bit more about the amount of data, whatever, is necessary to train the TensorFlow model. So if I'm interested, for instance, in handwriting recognition, I could maybe train that with specific people who, their handwriting, and I wanted to know how many samples of that I would need in order to get a confidence ratio higher than maybe 70%. That's possible with current technology. Thank you.
Well, the answer to that is as much data as you have.
Yeah.
And you said 70%?
Yeah, 70% confidence ratio. I mean, like, the question is how much, a lot of times these models, in order to be trained, you have to train them a lot with lots of data
Yeah.
to get good results. So if I'm trying to solve a problem that nobody's looking at, or if I have a specific use case, you know, with specific people and their handwriting, if it's how much of their handwriting do I need to capture in order to recognize that,
Sure.
you know, with more than 50% would be good. If that kind of if you can tell me.
So that kind of
I don't need- I don't-
information
I
is
don't need
not
a-
like, I can't say, oh, it's 50 million
No, that's
samples.
fine. That's
you know,
fine.
I can't
yeah,
do that.
just give me
but
like a ballpark figure if that's
so
possible.
even the ballpark, it would
Yeah.
depend on the kind of what you're trying to train. What's the kind of problem? How many possible
Right. Okay.
variables go into that?
I see. Yeah.
So
Yeah,
it's
that's-
very, very dependent.
Okay.
And if your problem is specific, you don't need as much data as if there are. You don't need as much data if your problem is specific,
Right.
as if it was more general, or there are lots of variables that could go into potentially, you know, helping you narrow down what
Yeah.
an actual
Yeah.
valid versus non-valid response
Okay.
would be. Yeah.
Okay.
So
And
I think you'd have to analyze, do an analysis
I
on
need
that.
to, it would take some work, right?
Yeah.
Yeah.
But
of course.
I mean, start with whatever data you have.
Okay. Okay. I'll try that.
And then see,
Okay.
yeah.
Thank you. And one more thing, with accents in the voice API, for instance, the Brazilian accent's a little different than most accents that I've heard in English. So like the TH is an F, and sometimes they mix vowels, and
Sure.
you know they don't. The T isn't really clear. It's more like a ch, right? A lot of times when it should be a t, right? So I wanted to know if you know if we can look at that in the model, if there's a way for instance, for them to recognize the Brazilian accent. Is there any trouble with that?
So one of the cool things about, so if you're using the API, I would just have that caveat again. It is a black box. There's nothing you as a user can do to change how it behaves. Now, if you did have some speech recognition, well, actually, I'll take that back a little bit, because if you know that your speech API is being used in an app mainly for Brazilians, for example, and then there was a tendency to replace something else for something else, you can use a parameter function to say, okay, if you hear this, this is probably what it should be.
Okay, and so
if there's a finite list of things like that, then that's a parameter that could go into the request you send the API.
Okay. So I can do that, and it feeds into the API. These parameters, as you call them.
Yeah. So there's the request you send to the API is, you know, the actual words that were spoken.
Right. Right.
As well as the parameters that tell you what you should replace something else with.
Oh, okay.
Yeah.
Okay.
So it's a TH with whatever else.
The problem is that's also variable, and so it's a really hard problem. And I was thinking about how maybe if it could maybe recognize the arc of the difference between these two accents. I mean, it's a really interesting technology.
It is, and it's not, you know, it's not perfect by any means.
Nothing is. Yeah. Okay. Well, thank you very much for your time.
Thank you. One more question in front. Oh, go ahead.
Hi, hello. I have two questions. One regarding about natural language processing. I'd like to know in different writing, like Japanese or Muslim writing, how is the accuracy in identifying the ideograms, and how is the image processing? And another question is about the big issues. How machine learning can be applied in climate change? There's a big example in agriculture that I had seen in internet before, and in climate change or government services. How is the access to this ownership with the countries? How is the barriers that you're facing?
Okay, I'll answer the first one. I'll try to answer the second one. So the first one, you said for languages such as Japanese or symbolic languages, essentially, how is the translation? Is that correct? Okay. So historically, it's not been very, very good, but very recently, there were updates made to the NLP API to use context in translation. So before, translations used to be symbols by symbols, word by word. But now it's based on the context of the words surrounding it. And so rather than just saying, okay, this symbol is this symbol is this symbol is that, you're using the context of the surrounding words to create better phrases and to give actual reasoning to the sentence you're translating. So short answer is that it's getting better. It's a lot better today than it was this time last year. But a lot of work is being put into recognizing how to do better translation for different kinds of languages. For your second question, using machine learning in the big issues, climate change, and so on, I think I'm not qualified to answer that question, unfortunately, but it is something that I would love to see happen.
Hi, Onome. I would like to know if is there an API to take measures of a picture?
To take measures?
Maybe of a picture, of objects in a picture, with maybe a reference of height or...
So you mean to get dimensions, how long things are, how short things are?
Yeah.
None that I know of. I think that would be a very hard problem to solve, right? Because if you think about, I mean, it depends on the angle of the picture, the perspective, whether it's zoomed in or zoomed out. Is this a specific problem you'd like to solve? We can talk about it afterwards.
So we'll talk later.
Okay.
Thank you.
All right, I think that's it. Okay, one more here. I can give you my mic. It's really far.
Thank you. Just the legal part of the TensorFlow, can it be used in commercial products?
In what?
Commercial products, I mean, license.
So for TensorFlow, all of the data is kept on your side, right? Because you create the models, and so you own the data. The data never really leaves your server. For the API, it's a little different because I mean you're sending the requests to Google, to the APIs. But for TensorFlow, if you create your own models, then the data lives with you. Yeah, the license. No, it's not a problem, no. As long as, you know, even though it's open source, it is, like when you create any models on TensorFlow, it is your IP. Yeah. Mm-hmm. All right. I think that's it. Thank you guys very, very much, and thanks for coming.